Hello students, welcome to this lecture number 9 on chemical bonding and molecular structure. We know there are some limitations in the Lewis concept. What are those limitations? First limitation, that it could not able to explain the formation of the bonding. First, that is the main limitation, I would say. It could not able to explain how the atoms bonds with itself, or what is the basic necessity of formation of the atomic bonding. Second thing, that it could not able to explain why there is a difference in the bond length and the bond strength of the molecules like hydrogen and fluorine. Hydrogen having the bond length is about 74 picometer and its strength is 435.8 kilojoule per mole, whereas fluorine is having the bond length of 144 picometer and its bond strength is 155 kilojoule per mole. It could not able to explain why there is a difference of this bond length and bond strength, in spite of the fact both the molecules has been bonded covalently with a single pair of electrons. And apart from this, there is another limitation, that it could not able to help us to predict the shape of the molecule. Another theory we have already discussed, that is the valence electron pair repulsive theory. This theory also can able to predict the shape of a simple molecule, but it would not able to explain it theoretically. And another thing, that this theory is applicable for the compounds of the p block element, so it has a limited applications. To overcome all these limitations, two important theory was put forward by the scientist, which is based on the quantum mechanical principles model, and those are the valence bond theory and the molecular orbital theory. In this lecture, we are going to discuss one of the theories, that is the valence bond theory. Today's lecture will be concentrate on the valence bond theory. Not only gives you the shapes of the molecules, but it also helps you to understand the formation of the bonds with the atoms. This is a very important theory. This is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Valence bond theory has been developed by two scientists, Hitler and London, in the year 1927, and it is further been developed by the Pauling and the others. To understand the valence bond theory, what we need to have some knowledge about the 3-4 things. Number one thing, that we must know what is atomic bonding, atomic orbital. We must know what is atomic orbital, number one. Number two, so the 4 things we need to understand, we should have the knowledge. That is atomic orbital. What is that? We already discussed in our atomic structure chapter, and electronic configurations also we have discussed. And these 2 things that we are going to discuss, that is the criteria of atomic orbital overlapping, and 4th thing that we will be going to discuss, the hybridization. Right? So to understand the valence bond theory, we will proceed with the examples of the bonding of the simple molecule, that is the hydrogen molecule. Suppose hydrogen molecule has been composed of the 2 atoms, atom A and atom B. Suppose the 2 atoms Na, A and B of the hydrogen atoms, having the 2 atoms, that is, suppose it is A and B, and A atom is consisting of the nucleus Na and electron Ea. B atom of the hydrogen consisting of the Nb and Eb. Nb is the nucleus and Eb is the electron. When these atoms are very far apart, what is going to happen? There is no interaction between them. But when it comes closer to each other, there will be the interaction of the forces. Number one force, that is the attractive forces, and number two, that is the repulsive forces. Attractive forces we can see from this diagram. That is here, this is the composition of the atom A. It is a nucleus and it is the electron. In the atom B, it is the electron and it is a nucleus. Initially, in the atom itself, there is an attractive force between them. Na, that is nucleus and the electron, both the A and B atoms. But when it is coming forward to each other, there will be the interaction force of attraction. We can write this, the force of attraction. Force of attraction between them, that is between the nucleus of A with the electron of B atoms, and on the other hand there is the electron of the A and the nucleus of the B. There is the attractive forces, and also there is the repulsive forces you can see between the nucleus and between the electrons. Initially, what is going to happen? The attractive forces is more than the repulsive forces. We can write this attractive force is greater than the repulsive force. So what is going to happen? The atom will be becoming very closer to each other, and with this process there will be the changes in the energy that we can understand from this graph. So we can understand when the two hydrogen atom is far apart, at that time the potential energy is zero because there is no interaction. But when it is closer, suppose this is a point where it is closer, at that time there is a decrease in the potential energy that you can see from this gap. It is decreasing. Energy is zero and it is giving minus, means it is decreasing. When and as the time comes, at the even closer and closer, there will be the further decrease of the energy, and when it is comes to this point where their energy will, you can see it is at the minimum level. It is at the minimum level, and it is, that is 435 kilojoule per mole. When their distance, internucleus distance between the two hydrogen atom is 74 pm, and if we go beyond that, we want to go even more closer, then what is going to happen? There will be the increase in the energy. So that will be the point, there is a minimum energy of this system, and at that time we will call that is the formation of the hydrogen molecule with these two atoms. One thing you can understand from here, that when these two atoms are at this point, when 74 pm, this length is the bond length, and this energy has been released because hydrogen atom, when is the hydrogen in the atomic form, they have some energy, and when it is the molecule form, they have the energy which is very less, and there will be the liberation of the energy, and at that time we will say it is at the minimum energy point, and that is the basic thing that we must understand here that that is the basic thing for formation of the atomic bonding. Why this atom bonds with itself, that is the main reason that lowering the energy. So you can see how the atoms form, the hydrogen atoms form the bond, and why it is having the bond length of 74 picometer, and why it is having the bond strength of this 435.8 kilojoule. So we understand this is the point where the atom achieves the minimum energy level, and in this state we will say the atoms make the bond with itself. So we understand from this valence bond theory that how the atom's formation of the bond is being occurred. Now we understand the main thing, that valence bond theory, that is the overlapping of the atomic orbitals. As the atoms, hydrogen atom in this case, is very much close to each other, when they form the bond and it is become the molecule and it is at the minimum energy level, what is going to happen? The atomic orbitals are partially interpenetrated with each other, and this merging, partial merging of the atomic orbitals we will call the overlapping of the atomic orbitals, orbital overlapping. And this result into the pairing of the electrons, and this pairing of the electrons is resulted the formation of the covalent bond. And this is the main point, main theory in the valence bond theory, that when, as per this overlapping, atomic overlapping concept, the covalent bond is formed by overlapping of the atomic orbitals with each other, and it will going to make a pair of the electrons in the valence shell which is oppositely spin. So we can understand the atomic or overlapping of the atomic orbitals. So we can write here atomic orbital overlapping. Atomic orbital overlapping is basically the merging of the atomic orbitals. This is the partial merging. We can write partial merging of atomic orbitals. Atomic orbitals, and which results into the pairing, of the electrons. Which is oppositely spin. And in this fashion we can say that 1s orbitals of the two hydrogen atoms, how hydrogen molecules formed, H2 molecules form. H2 molecule, that is the overlapping, we can say overlapping of the half-filled orbitals, 1s orbital. Overlapping of the 1s orbital is the hydrogen covalent bond. In the hydrogen molecule, covalent bond is being formed. Overlapping of the half-filled 1s orbitals in the hydrogen molecules. Okay. Now, as the molecules are very much close to each other, and it comes for making the bonds, making the covalent bonds, and atomic orbitals is very much close to each other, at that time the overlapping may be positive, may be negative, or may be zero overlapping, and that is depends on different factors. So we can write this is the criteria for overlapping. Criteria for overlapping. What are the criteria for overlapping? Now, what is the basic factors? Two factors basically that is going to govern. Number one, that is the sign. Sign means that is the phase. Phase of the orbital wave functions. Shape of the orbital wave functions, or we can say the surface boundary diagram. Number one, and number two, that is the direction of orientation. Direction of orientation. Direction of orientation of the amplitude of wave function, amplitude of electron wave, amplitude of electron wave, but we can say wave function. So there is basically two things that is going to influence while there is a overlapping of the atomic orbitals. That is, number one, the phase, which is defined by the sign, and direction of orientation of the amplitude of the electron wave. That is two things that is going to be influence the criteria, that is the overlapping, whether it is the positive overlapping, whether it is the negative overlapping, or whether it is a zero overlapping. Now we understand diagrammatically with the help of the boundary surface diagram of these atomic orbitals. We understand what is boundary surface diagram? That will give the shapes of the orbitals that is defined for the different orbitals that we already studied in our atomic structure chapter. There are basically three types of conditions of the atomic orbital, overlapping of the atomic orbital, that we already discussed. One is positive, or we can say it is a in phase overlapping. One. Second thing, that is the negative, or this is out of phase overlapping. Out of phase overlapping and the overlapping. This is basically the surface boundary diagram. You can see here all the overlapping is positive or in phase overlapping. Here it is given the negative or out of phase overlapping. Here you can see there is a plus point when the atomic orbitals overlap with each other, that it is in the same phase. This is plus and this is plus, means it is the same phase, and it is in the same orientation. Direction or orientation is along the, you can say, internuclear axes. So at that time, this overlapping we call is a positive or in phase overlapping. Same thing you can see here. Here boundary surface diagram have the plus, this is the plus sign and this is the minus sign. So they are not in the same phase. So at that time, this overlapping we will call the negative overlapping. At that time, there will be no formation of the bond. Bond will not form. Bond will form only in this case when there is a positive overlapping. And you can say, in spite of this fact, there is a orientation, direction or orientation same, but due to the phase is different, we call it is a negative out of phase overlapping. Second instance, you can see P and S, P orbital and S orbital. You can see both the cases. You have to see the, this is in the sign is same. Matlab all these two things that you can see here, that here there is the same phase. That is why it is the positive overlapping. Here you can see the phase is different. This is minus and this is plus. So this overlapping will be the negative overlapping. And this we can understand for the other case also. Understand this overlapping of the px orbitals. These orbitals positive, this overlapping we will call it is a positive overlapping, where you can see that both the orbital has been overlapped with the same phase. When it is plus sign, and the plus sign, minus sign and minus sign. Whereas in this case, this is will be the negative overlapping, where the orbitals has been merged, orbital has been overlapped with the in phase, out of phase overlapping. So we will call it is a negative or out of phase overlapping. Here also you can see that for the py orbitals, when they will overlap, this overlap we will call the positive overlap or in phase overlap, whereas this type of orbital you can see py orbitals, that is has been merged with the out of phase orbitals, out of phase, that is here you can see the both the orbital has been merged with the different phase. So we got the out of phase or negative overlapping of the orbitals. Now we understand the zero overlap. This is also you can say it is a zero overlapping, because that orientation, direction of orientation of the amplitude at the different direction, it is in 90 degree with this px orbital is 90 degree with the py orbital. So at that time, if the orbital there is a overlapping occurs, this will be the basically due to the different orientation, this overlapping will be called it is a zero overlapping. So we understand what is in phase overlapping or positive overlapping, what is negative overlapping or out of phase overlapping, and number third, that is the zero overlapping, and that will be governed by the phase of the wave function, phase of the wave function of the electron. And when the phase is same, when the overlapping is, when the phase is same, at that time we will call it is a positive overlapping. If the phase is different, then we will call it is the negative overlapping, or we can out of phase overlapping. When the orientation of the two orbitals is different, at that time we will call it is the zero overlapping. Now on the basis of that overlapping, we can divide the covalent bond in different ways, that we will now understand. Now we are going to understand the types of covalent bond. Types of covalent bond. Basically, on the basis of the nature of overlapping of the atomic orbitals, it has been classified into two ways. Number one, which is called the sigma bond. Sigma bond. And number two, that is the covalent pi bond. So two types of bond on the basis of the nature of the overlapping of the atomic orbitals has been classified. One is sigma bond and other is pi bond. Now let us understand what is sigma bond. Sigma bond is basically being observed It is basically formed by the overlapping of the atomic orbitals with the end-to-end overlapping or at the internuclear axes of the molecules. This overlapping is done at the internuclear axes with end-to-end overlapping. And this overlapping also called the axial overlapping or head-on overlapping. And there are different types of overlapping that we are going to discuss for this sigma bond. Number one, that is the SS overlapping. SS overlapping is basically been formed when there is a overlapping of the unpaired, overlapping of half filled, or we can say half filled vacant s orbitals. So this overlapping we can say like this. This is one s orbital and this is another s orbital. We can write this s orbital, another is s orbital. So they are basically half filled and they will produce the overlapping which is called the SS orbital overlapping. This is called the SS orbital overlapping. When the s orbital, half filled s orbital overlapped with another half filled of orbitals, this will be called the SS overlapping. Second type of overlapping we see, that is the SP overlapping. SP overlapping. In this case, one s orbital and other will be the p orbital. Other will be p orbital and s orbital. So we can write this is a s orbital and these are half filled. So it will going to create this overlapping like this. So we can say it is a SP overlapping. And these are basically the half filled orbitals. Another, that is the for producing the sigma bond, another type of orbital overlapping we can see, that is PP overlapping. PP overlapping. P orbital overlapping, that is being like this. So you can understand, for formation of the sigma bond, there is basically the overlapping at the internucleus axes and the half filled orbitals. Three type of overlapping we see, that's SS overlapping, SP overlapping and PP overlapping. And that is how the covalent bond types of the sigma bond is produced, is formed. Second, that we are going to understand, that is the pi bond. Pi bond is produced by the overlapping of the half filled orbitals which is parallel to each other and perpendicular to the internuclear axes. And this type of bond you can observe here. So this overlapping also called the sideways overlapping. This overlapping has been done sideways, side of the overlapping, and in this overlapping what is observed that there is a saucer type, two saucer type is produced. Here you can see that is a internucleus axis, and you can find there is two plate type. You can say there is a plate, two disc type. This is called saucer type electron clouds. Two electron clouds, that is the above the plane of the molecules. This is one electron charge and this is another electron charge is producing with this pi bond. Now we are understand the strength of the bond. Strength. Which factor is going to influence the strength? It is basically the extent of the overlapping. When the overlapping will be higher, at that time the strength of the bond will be higher. In the sigma bond, you can see the strength is higher as compared to the pi bond. Why? Because of this fact, in the sigma bond, the overlapping between the orbitals is much greater than the pi bond. Pi bond, there is a sideways overlapping, but in the sigma bond there is a head-to-head overlapping, end-to-end overlapping, axial overlapping. That is why sigma bond will have the higher strength than the pi bond. And when there is a double bond, then one bond will be the sigma bond and other bonds will be the pi bond. So that is all for today's lecture. In this lecture we have discussed the introduction of the valence bond theory, that what is the utility of the valence bond theory, how valence bond theory help us to understand which is not we are able to explain or understand in the Lewis theory or valence shell electron pairs theory. In the next lecture, we will be going to discuss the most important part, that is the hybridization. Hybridization is a very, very helpful concept to understand the shapes of the polyatomic molecules. Thank you very much for watching. Thank you.